Okay, now we are over on the other side of the South Pacific. Okay, we're on the southwestern corner of South Africa. Here's a little black map, and this is where the Benguela Current exists. And these currents are created, the Benguela Current is created through coastal winds that create an upwelling system. And part of the upwelling system is the creation of an upwelling jet. And so what this map shows is that the Benguela Current creates actually a set of upwelling centers. There are actually 6 upwelling centers. And the left image shows a evidence of one of these upwelling centers, the Lüderitz upwelling center, in terms of sea surface temperature. Can you already know that only mechanism that can lead to very cold surface water in these regions, and you can see it's less than 12 degrees Celsius, and it's more than 3, 4, 5 degrees colder than ambient water. The only process that can do that is upwelling. Upwelling lifts up colder water to the surface, and by doing that, it also lifts nutrient-rich water into the euphotic zone and triggering plankton bloom. All right, so this is one feature. I want to show you some observations of currents associated with the system. Okay, let's see on the next slide. Here are Walvis Bay measurements of current component. So let's see whether Walvis Bay is on the previous slide. We just go back one. This Walvis Bay is the one of the northernmost upwelling centers here. And you see this is number 2, and we have some measurements. Okay, so there are people going out, installing a mooring, okay, and measuring currents. And what's shown here are current components, okay, as a function of time. So the x-axis is time. You can see here in this top graph, January 2004, February 2004, you get a time series along the x-axis over almost 2 years. And the vertical axis is actually depth. Okay, and what's shown are the measurements of cross-shore current component, whether it's offshore, whether it's onshore. And it doesn't show the surface, okay, it only starts at 20 meters below, but you still capture the surface Ekman layer. You can see that there are times offshore currents, and then you have some times where you can't really see it near the surface. Anyway, during the times of the strongest offshore currents, you also get an onshore current as depth, and this onshore current is the agent of moving water towards the coast up into the ocean. Okay, and this is the onshore-offshore Ekman layer transports that you have. Okay, and in terms of speed, you can see that there are fairly weak speeds associated with that. Something like maybe 5 centimeters per second offshore current, and onshore current might be similar. You can also look at the alongshore currents, and this is the alongshore. This is the upwelling jet, and here you get upwelling jets of 10 centimeters per second. Okay, again, you only have the currents which are below 20 meters, but you can see that these clear events of you have the creation of stronger northward upwelling jet. You can see that there is in this area of Walvis Bay, there's a significant variability. In the region, there's also an oxygen-poor undercurrent, so sometimes you actually have the dominance of this oxygen-poor undercurrent reaching very, very close to the surface, the pool water. All right.